yesterday we solved equations with these fractions in them. Today we're solving inequalities. Now our strategy is going to have to be very different. Because yesterday what we did is multiply to get rid of all the fractions, right? Here's the problem. If I just start off multiplying by x plus 5, we don't know what x is. So do you know if x plus 5 is a positive or a negative number? No. What happens if you multiply by a negative in an inequality? It flips. It flips. So I don't know if it's positive or negative, which means I don't know if I can flip my sign or not, which means we can't multiply that. So in these rational inequalities, you cannot multiply by a variable. So here is what we're going to do instead. Does everybody have a graphing calculator? All right, we have graphed these types of equations. Okay, that's what we were doing in the last section last week. We spent every day doing it. And we could go through the process and graphing these. We know that what happens at negative 5?
No solution. Crosses the x. No, never mind. No solution.
It's the vertical asymptote at negative 5, right? And at negative 3, that's where it hits the x-axis. So those are the places where our graph might switch between positive and negative. So our strategy is going to be to get a single fraction on one side and 0 on the other. And then what I want you to do is set the top and bottom equal to 0. So negative 5 and positive 3 are the two places where this might switch between positives and negatives. Do we want the positives or the negatives? Greater than 0 means we want the positives. Okay. I am not going to do the full graph here. I'm just going to make what's called a sign line. So we are going to decide if these things are positive or negative. So I want you to go to your calculator, and I want you to graph this rational expression x minus 3 over x plus 5. Yes, parentheses around both. Since it just means both the top and the bottom. Oh, no, double parentheses are not needed. Okay. So if I look at this graph, before we get to negative 5, okay, negative 5 is my vertical asymptote here. Before negative 5, was my graph positive or negative? Positive. It's above the x-axis, so that was positive. Between negative 5 and 3, my graph is negative. It's below the x-axis. Then after 3, my graph became positive again.
Plus minus plus.
I did not.
Zoom standard.
No.
You want to fly by?
There you go. You're welcome. All right. So we have to tell where this was positive. So it was positive before negative 5 and after 3. So what would the interval be here? Is anyone else having calculator problems?
I just Zoom standard.
Zoom standard.
Is that all we're doing today? Perfect. Just one problem?
All right. So is this one okay? Let's look at, I'm going to kind of change the order of my examples, I think. I want this one to be next.
We want 0.
Our strategy is to have a single fraction on one side and 0 on the other. So we have to bring this over. Now, can you just go ahead and subtract these? The denominators match, so we can, so I'm just subtracting this over. Since the denominators match, we get 7 minus 1 is 6 over x plus 2 greater than or equal to 0. Alright. So I told you once you got this format, you really just figure out what makes the top and bottom 0. That's where we can change between positives and negatives. Does 6 ever equal 0? Okay. What makes x plus 2 equal 0? So when I make my sign line, negative 2 is the only place where it's going to change. Then we are going to graph this. The 6 over x plus 2. You need the x plus 2 in parentheses. So when I look at this, we could tell negative 2 is this asymptote. Before the asymptote, my graph was, after the asymptote it was, okay, which ones did I want? Positive. Okay, equal to means bracket. Now let me ask you a question. Does this graph ever equal negative 2?
No.
Why not? That's the asymptote. Even if it has an equal to, the bottom of the fraction, we know that cannot be, so that would have to have a parenthesis. So it's negative 2 to infinity with parentheses.
So just in this, we just disregard the bracket.
Sometimes we might have a bracket if it's from the top of the fraction. Because the top of a fraction can equal 0, the bottom cannot.
Is that why, like, sometimes it crosses?
Mm-hmm. What? Because I wanted greater than 0, so greater than would be the positive section.
Be confused. We're fine. Idiot. I'm an idiot.
They're so nice to one another. Alright. Any other questions here? Let's look at this one.
This is a color of
Oh, does that mean we have to set it equal to 0?
We have to get it equal to 0.
yeah, just subtract.
Can we just stop at the first two?
So if I subtract this 4, can I just make it 3x minus 3 on top? No. In order to add or subtract, we have to have a common denominator. This is like 4 over 1. If I want to make a common denominator, what do I have to multiply it by?
2x minus.
Let me do it on top and bottom. Because this is a minus, I'll go ahead and distribute that negative. So then we now have a common denominator, so we can put these together. 3x minus 8x, 1 plus 12. Okay. So we had a little extra work because we had to get that common denominator. Now, we have a single fraction on one side and 0 on the other. So now what do? Set top and bottom equal to 0. So 3 halves and 13 fifths are where it can change sign. I'm going to graph it to figure out what my sign is. So I am graphing this fraction need to put parentheses around both the numerator and denominator. Three
On your
halves.
reaction, I think that's not supposed to happen.
Huh?
Based on your reaction, I feel like that's not what was supposed to happen.
No, it was fine. Just making sure. Okay. This is my asymptote. Before the asymptote, before the 3 halves, my graph was negative. Okay, immediately after, our graph was positive. And then we hit our x-intercept, and after that it was negative. Looking back here, which ones did I want?
Negatives.
Less than 0 means negative. There's no brackets because there's no equal to. So my answer is negative infinity, 3 halves. Is this one okay? I would like for you guys to try this. We have to subtract over the 1. Okay, this is like a 1 over 1. We need a common denominator, so you have to multiply it by x plus 4 on top and bottom. 5 over x plus 4 minus x plus 4 over x plus 4. We take that negative and distribute. Now the denominators match, so we can put them together. So we get a negative x plus 1 greater than or equal to 0. Is everybody with me to this point?
Yes. Oh, you distributed negative
Okay. Is there another question? Did you ask something? At this point, it's set up the way we want. So we set top and bottom equal to 0. So we get 1 and negative 4. So those are the places where we could change signs. We graph this, parentheses around the top and bottom. So then when I look at this graph, starts out negative before the negative 4. Between negative 4 and positive 1, the graph was positive. And then after 1, it became negative again. We said greater than or equal to 0. So that's positive. Equal to means brackets, but can it equal both a negative 4 and a 1? Which one can't it be? Negative 4, because that's the vertical asymptote. That makes the bottom 0. But it can equal to 1. That was the x-intercept on our graph. So our answer is parentheses negative 4 comma 1 with a bracket.
I'm sorry. Is there an octopus in a hat?
What?
Your little thing.
Oh.
Like the octopus is on something.
Alright, let's try one last problem for the day.
Okay.
One last problem, 50 steps.
Oh, it's no worse than the other.
This is
Is
did
worse
the
than
second
the others.
Better be.
What letter is it? E.
E. Sorry, I'm skipping around today. Okay, what do we have to do first?
Do it on the side.
We need them on the same side, we need a common denominator. Okay. The first denominator is x plus 1. What does it need to look like the second one? We'll do it on top and bottom. Second one has x minus 3. It needs so on the top, if I distribute, you get 4x minus 12, and I'm just going to leave the bottom as x plus 1 times x minus 3. Multiplying it out won't benefit us at all. Minus, this would be 2x plus 2.
Do it double parentheses?
Yes. Distribute the negative. So 4x minus 2x is 2x. Negative 12 minus 2 is negative 14. Okay. Before we graph it, let me ask some questions. What are the numbers that make this 0? So what would make the top 0? What makes the bottom 0? Okay, so we have 3 numbers this time. Put them on our number line, small to large. So we can change sign 3 different times here. When you go to graph this, make sure you put parentheses around the top, and then the bottom you'll have that double set of parentheses. Okay. Not all. So if we look, the graph starts before negative 1. My graph is negative. Okay, between negative 1 and positive 3, the graph is okay. Between 3 and 7, my graph is okay. It's kind of hard to tell what happens after 7. If we needed to adjust this, we could. I'm gonna just do. If I just focus on that,
He just doesn't.
it's a horizontal asymptote, but it did switch. It did go from the negative and it crossed over and it's just barely positive. It's an asymptote, so it's not very positive. Okay, so here's the thing. The signs should switch unless something's squared. Alright, so when I look at this, like none of these have a square on them, so the sign should alternate every time.
So
It's a multiplicity.
It's a positive.
bracket on
Yes.
the 7?
Can you just plug in numbers?
Yeah, you could absolutely just take like an 8 or a 10 and plug it in and see if you get a
Is
positive.
there always gonna be one more sign change in the amount of numbers you have in the?
Yep. Alright, so which ones did I want? Positives or negatives? Less than 0 is negative, so I have 2 sections that were negative. Do I need any brackets this time?
Oh, 7.
I didn't have an equal to on my inequality. So negative infinity to negative 1, union 3 to 7. Okay. We are going to practice this more tomorrow, but I have a 5-question math Excel assignment for you today. So you've got time to work on that.
I did my math